Welcome to the chapter Motion and Measurement of Distances.
This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
define the terms rest and motion. Describe the different types of motion. Discuss the story of transport. List the conventional methods of measurement. Understand the need for measurement. Explain the invention and standardization of the scale.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
Generally, we see many examples of motion around us, like birds flying in air, buses, autos, cars, bikes moving on roads, trains on railway tracks, etc. Similarly, the objects like trees, buildings, electric poles, etc. appear as if they are in motion when we observe them from a moving bus, whereas the same objects appear at rest when we observe them while walking. Answer the following questions. How do we decide which object is moving and which one is at rest? Are these trees, buildings, electric poles, etc. really in motion or at rest? To find out the answers to these questions, we need to understand the terms motion and rest. To understand the idea of motion and rest, take up the following activity. Observe the conversation between two boys standing beside the road.
Hey, I got a small doubt. What is the state of motion of the tree?
It is at rest.
What is the state of motion of the bicycle?
It is moving.
What is the state of motion of the boys on the bicycle?
They are also moving along with the bicycle.
How do we decide that the bicycle and the boys sitting on it are moving?
With respect to their surroundings, the position of the bicycle and the boys are changing with time. So, we can say that they are in motion.
Now, observe the conversation between the boys on the bicycle.
What is the state of motion of both those boys standing beside the road?
They are in motion.
What about the state of motion of the tree?
It is also in motion.
What is my state of motion then?
You are at rest.
What is the state of motion of the bicycle we are riding?
It is in motion.
From the discussions, a body may be at rest with respect to one set of surroundings and at the same time be in motion with respect to another set of surroundings. Thus, motion is relative to the observer. Definition of motion. An object is said to be in motion if it changes its position with respect to its surroundings in a given time. Definition of rest. An object is said to be at rest if there is no change in its position with respect to its surroundings in a given time. The motion of an object can be classified into three types based on the path taken by the object in motion. They are translatory motion, rotatory motion, oscillatory motion. Let us study about the translatory motion. If an object like a bus moves in a straight line in such a way that every point on the object moves through the same distance in the same interval of time, then the motion of the object is called translatory motion. There are two kinds of translatory motion. They are rectilinear motion and curvilinear motion. Click each tab to know more. Rectilinear motion. If an object or a body in translatory motion moves along a straight line, then the motion is called rectilinear motion. Following are the examples of rectilinear motion. Soldiers marching in a parade. Ball dropping from a height. Movement of bicycle on the road. Running race along the straight line. Curvilinear motion. If an object or a body in translatory motion moves along a curved path, then the motion is called curvilinear motion. The following are the examples of curvilinear motion. Bus moving along a curved path. Ball thrown by a boy. A javelin thrown by an athlete. Running race along a track. Now, we are going to study about the rotatory motion. Consider a ceiling fan. Mark points A, B, and C on any one of the blades of the fan. When the blade of the fan moves, the points A, B, and C on the blade move to A1, B1, C1 first, and then move to A2, B2, and C2 position. As a result, each point on the blade moves in a circular path around the center of the fan, which is fixed. Here, we observe that the position of the fan is fixed, but the blades of the fan are changing their position continuously in a circular path around a fixed point. This type of motion is called rotatory motion, and the imaginary line passing through this fixed point is called axis of rotation. Definition. Rotatory motion means that motion of all particles of a moving body follows a circular path with respect to a fixed center or axis of rotation. Let us perform an activity to observe the both translatory and rotatory motion. Click each tab to know more. Take a tennis ball. Place it on the surface of a table. Now, push the ball with your finger. Observe the motion of the ball. We observed that the ball moves from one place to another place on pushing it. The ball moves from one place to the other place, and all the particles of the ball also move along the direction of motion of the ball as we push the ball on the surface of a table. Hence, the ball is said to be in a translatory motion. Similarly, each particle of the ball moves in a circular path about a particular line when the ball rolls on the surface. Therefore, it is in rotatory motion. Hence, we can conclude that the ball possesses both translatory and rotatory motion at the same time. Let us study about the oscillatory motion. We must all have had a chance of having played on a swing. The swing goes to one side, comes back to its mean position, and then goes to the other side, and this process is repeated many times. Similarly, the pendulum of a wall clock is also in to and fro motion along the same path of motion. This to and fro motion of the swing and pendulum is termed oscillatory motion. Definition: the to and fro motion of an object about a fixed point, always following the same path, is called oscillatory motion. Story of transport. During the ancient times, people had to walk from one place to another place. Later on, people used animals like donkeys, horses, mules, elephants, oxen, sled dogs, and bison for transportation. The modes of transport that we come across today were not available in those days. People used to take a long time to reach distant places. After the invention of the wheel, man started using animals to pull vehicles that moved on wheels, and thus bullock carts and chariots came into existence and made transportation of goods and people much easier. The invention of the wheel revolutionized transport, and wheel design was improved over thousands of years. The invention of steam engine introduced a new source of power. The development of trains greatly reduced the time taken to travel from one place to another. Later on, petrol and diesel engines were invented, which revolutionized the modes of transportation. Likewise, the time taken to travel distant places was further reduced with the developments of aeroplanes. Motorboats and ships came to be used as means of transport on water. Modern means of transport, such as cars, buses, trains, and aeroplanes, allow us to travel faster than those used in earlier times.
Introduction to measuring. We use a scale to draw margins in our notebook. The scale contains some numbers on both sides. Similarly, when we observe the collar of our shirt, we find a label with a number on it. These are the examples of measurement used in our daily activities. Now, let us perform a simple activity to measure the length of a side of a table. Click each tab to know more. Select a table in your classroom. Measure the length of one side of the table with a hand span. Count the number of hand spans taken to measure one side of a table and note down in a table. Ask your friends to repeat the measuring of the same side of the table. In this activity, we observe that the number of hand spans of different people are different in measuring the side of the same table. Measure the length of the classroom with the foot span. Note the number of foot spans taken to measure the length of the room in a table. Now, ask your friends to measure the length of the room with foot spans. In this activity, we observe that the number of foot spans measured by different people are different from one another. From this activity, we have learned that the count of hand spans for measuring the side of the table is different for different persons. Similarly, the number of foot spans while measuring the length of a classroom are different for different persons. Here we do not get the same measurements because hand spans and foot spans are different from person to person. List the conventional methods of measurement. We use the conventional methods such as hand spans and foot spans to measure the length of the small objects. Similarly, we measure the string of flowers with the hand, that is in cubits. Moreover, strides are used to measure the length and breadth of the ground. In our play of Siragona, Gilli Danda or Billam Godi, we measure the distance with the stick, which is considered the unit of length to measure. Here, we will study about the invention of the scale. The invention of scale took many years. The story behind the invention can be categorized into three segments as shown on the screen. History behind the scale, evolution of the scale, standardization of scale. Click each tab to know more. History behind the scale. Many hundred years ago, people used to measure distances with hand spans, foot spans or strides. Once, a tall man went to a shop to buy 3.5 arms length of the cloth. I want 3.5 arms length of the cloth. The shopkeeper measured 3 arm lengths and added approximately another half arm length of the cloth. When the tall man measured the cloth with his arm, he found that cloth was not even 3 arms. This cloth is less than 3 arms. I have measured it correctly with my arm. Your arm is not the standard of measurement, but my arm is. No, not at all. My arm is the standard of measurement. This raised an argument between the tall man and the shopkeeper regarding standard of the arm to be considered. Not only this, people were arguing over measuring the lengths of the fields, robes and many other things. It was also difficult for them to measure a half or quarter arm length. Considering all the consequences in measuring, some sensible people got together and decided to have a scale of fixed length. This scale was made of wood or metal. In order to measure subunits, they marked this scale with several smaller but equal divisions. It was decided to use this scale to measure the lengths. At a place, people decided to use the distance between the nose and the tip of the middle finger of their king as a measure. This distance was called 1 yard. Wood or metal was used to make the scales of this 1 yard. The scale was divided into 3 equal parts and each part was called a foot. Each foot was further divided into 12 equal parts called inches. Each inch is subdivided into smaller segments. Even then, every country had its own scales and faced problems in trade and commerce. Standardization of scale. Observing the problems faced by people and nations in measuring, finally in France, it was decided that a certain length of rod made of platinum iridium would be called a meter. The meter was divided into 100 equal parts called centimeters. The centimeter was further divided into 10 equal parts called millimeter. This is the standard measurement we are using today, which is acceptable throughout the whole world. The original scale is preserved in a museum in France. 1 meter is a standard unit of length. We use meter as a unit of length and subsequently centimeters and millimeters as smaller units of length. Here, we will learn the way to measure long distances. We use different instruments like plain tape, rolled tape, centimeter scale of different sizes and made of wood, metal or plastic in our daily life. The thickness of the eraser can be measured easily with the rolled tape. Measuring long distances like length and breadth of a playground or agricultural fields, measuring distance between the school and our house, town to town, and even longer distances like country to country is impossible with meter as measurement. Hence, a larger unit is required to measure large distances. The larger unit is defined as kilometer, that measures larger distances. Now, let us perform an activity to know how to measure. Click each tab to know more. Ask your friend to stand with his back against a wall. Mark above his head on the wall with the help of a scale and a marker. Take the scale and measure from the floor to the mark on the wall. Record your observations in a notebook. Ask your other friends to measure the same distance. Record the observations in a notebook. In this activity, we observe that the same distance measured by different people gives different values. From this activity, we notice that the measurements taken by different people may be close to each other but not exactly equal, even though they used a standard scale. This difference in the reading is due to errors in measurement, which include not marking the point exactly at the top of the head, not using the meter scale in a proper manner, let us learn how to measure the length accurately using the meter scale. We use a wooden or plastic scale in our day-to-day work. It is marked in centimeters and millimeters. We use meter scale to measure the length of a table. Place the meter scale on the table such that the zero mark on the scale coincides with one end of the table. Note: the scale should be kept straight. Mark the point on the scale that coincides with the other end of the table with the help of a marker. Now observe the scale vertically above the end, where the mark is to be taken. If we observe from a side view, it would result in errors. There are some precautions to be taken while using a meter scale. Precautions. Click Tab to know more. Precautions. Place the scale exactly along the length to be measured. 0 point on the scale should coincide with the starting point of the length to be measured. Our eyes must be vertically above the point of coincidence of scale where the measurement is to be taken. Ensure that the ends of the scale are not worn out. Measure the length of an object more than 2 times and then take the average of these measurements for accuracy. That is accurate measurement equal to first reading plus second reading by 2. Here, let us learn how to measure the thickness of a material. Take 10 5-rupee coins of the same size. Place one coin above the other. Take the scale and measure the total thickness. Divide the total thickness by the number of coins to get the thickness of each coin. Similarly, we can calculate the thickness of the paper by measuring the total thickness with a scale and dividing it with total number of papers. Now, let us perform an activity to measure the length of the curved path. Click each tab to know more. Select a curved path and mark some reference points from A to E. Fix 2 pins at both of its ends. Take a cotton thread and tie a knot to the pin at the point A. Move the cotton thread along the points B, C, D and E. Note: the thread should be neither too tight nor too loose. The thread should be made to coincide with the curve. At E, cut the remaining part of the thread. Remove the thread from A. Place the thread straight along the length of the meter scale. In this activity, the thread is used to measure the length of the curved path. From this activity, the thread along the curved path gives the measurement of its length when placed along a meter scale.
Follow-up work.
Make a collection of action pictures showing living and non-living things in motion. Paste them neatly in a scrapbook. Under each picture, write the type of motion the picture shows. The distance between the numbers in a clock is exactly the same. Make a list of a few things that you observe in your surroundings with accurate distance between them. You have successfully completed the chapter Motion and Measurement of Distances.